Imaginary numbers. Final video project by Jasmine Parker. Why are imaginary numbers important? In real life, they are used in physics to show how electrical circuits work and how fluid flows around obstacles. In calculus, they make translations on plane easier than using sine and cosine, and they're imaginary, which means it's unicorn math. Lesson objectives: be able to solve problems containing complex numbers, be able to find additional roots when given imaginary roots, know how to convert irrational numbers to imaginary form, and build a polynomial using complex roots. Prerequisite skills: understand what I is and how to use it, add, subtract, and multiply with I, use FOIL to multiply binomials with I, and convert numbers to imaginary form. So I equals the square root of -1. It's imaginary because negative numbers can't be under the radical. Its standard polynomial form is a plus bi, where bi is the imaginary part and a is the real part. I equals the square root of -1. I squared equals -1. I cubed equals -I. I to the fourth equals 1. And I to the fifth equals the square root of -1, which is the same as I. I squared equals -1 because the square root of -1 times the square root of -1 cancels out the square root sign, therefore -1. I to the third can be factored into I squared, which is -1, and I, -1 times I equals -I. I to the fourth can be factored into I squared and I squared. I squared is -1, so -1 times -1 equals 1. I to the fifth equals I because it can be factored into I to the fourth and I. Since I to the fourth is 1, 1 times I equals I. Here are some problems to test your skills. Pause the video here, then press play to check your answers. I to the seventh can be factored into I to the fourth times I to the third. Since I to the fourth is 1 and I to the third is -I, the answer is -I. I to the 24th is factored into I to the fourth 6 times. Since I to the fourth is 1, it's still 1. Adding, subtracting, and multiplying. The process of adding and subtracting with I is the same as that of any variable. For example, 3i plus 2i is the same as if you were just to say 3 plus 2. Therefore, the answer would be 5i. The same goes for this next problem, 4i minus I. It's the same as saying 4 minus 1, therefore the answer is 3i. 10i times 8i equals 80i squared, but because I squared equals -1, you can say -1 times 80, which equals -80. This type of problem can be solved the same way. You first collect like terms, so -8 plus 3 equals -5, and 2i plus 7i equals 9i. Therefore, the answer is -5 plus 9i. Here are some problems to test your skills. Pause the video, then press play to check your answers. Once again, for these problems, you would just collect like terms. For the last problem, don't forget that the answer was originally 24i squared, but I squared is -1. So, FOIL to multiply complex polynomials. FOIL is an acronym that stands for first terms, outer terms, inner terms, and last terms. For example, 2 plus 3i times -9 plus 2i. When multiplied out, you would get -18, 4i, -27i, and 6i squared. You would then write these answers into a polynomial form. Once you've done that, you can collect like terms. 4i minus 27i equals -23i, and 6i squared equals -6. You can then continue to collect like terms until you get -24 minus 23i as your final answer. Here are some more problems to test your skills. Pause the video, then press play to check your answer. Once fully FOILed out, you should get 12ai, -3i, and 2i squared. Once you collect like terms, the final answer is 14 plus 5i.
Created using Powtoon.